Okay, guys, some of this stuff I've shown on previous videos, but we'll just start from scratch here. So this is day 2 of the review, which has actually been pushed to day 3 of the review. So let's call this day 3 of the review. We'll do unit test number 2 and unit test number 3 review. So I've already done this, but let's look over this. Remember, we have A, K, D, and C, and we have a function like this, right? And A is on the function. K is in front of the bracket minus D plus C. So we look at this and we want to talk about all this stuff here. 2 units to the left. 2 units to the left is here. So D is 2, but it's built in with a negative, so this is plus 2. Think of your parabola, and your parabola is over 2. The vertex of negative 2, let's say, it'll be plus 2 in the bracket. Okay, that's there. What do we have next? 1 up. 1 up is plus 1. Vertical stretch. Vertical in front, remember parabola again, when we stretch them vertically, and a number in front would change the step pattern. So think of it, that goes there, and then what goes here is this. We talk about the horizontal stretch of 4, but don't forget that what happens is 1 over k, or 1 over 4, is the number that goes here. So 1/4 is a vertical stretch of 4. The negative here deals with the reflection. The reflection is on the y-axis. X, y, this is the y-axis. So if I flip it this way, so it's here, I flip it over here, that is a horizontal flip. So again, negative on the x, not the function. Find the inverse. You swap the x for the y, and then solve. I added this here to keep it in y equals something equals b form. Here, you're going to have to complete the square first. So if you have something that's in standard form, you need to complete the square and put it in vertex form. Once it's in vertex form here, so you work through the whole process of completing the square, and then you swap them out. X for y, solve for y. Remember, when you get to this point, first you divide by 2, so that's here, and then after that you get rid of the square. The opposite sign, the opposite operation of squared is the root. So you get the root, and when you get the root, I want the plus and the minus. And again, the reason for that is that the root of 9 is 3, but it's also minus 3 because minus 3 squared is 9. So you put plus minus there, and then bring the negative 1 over. And then you can plot that guy. Okay, we're whipping through this, or I'm whipping through this. Here, the trick of the unit, it's go back up there, you have A, K, D, C. So you have K bracket X minus D. Here I don't have that. I have 2x minus 2. There's no bracket, so what you do is factor out the 2. When you factor out the 2, this changes to 1. So now I deal with this vertical compression of a third. That's a 2, so it's a horizontal compression of a half. Right 1, and then here down 11. Is that negative 11? I can't remember. It might be, if it's plus, I don't know. If it's a plus in your notes, it's hard to see stuff. If it's a plus, then it's up. I think it's plus in your notes. Anyway, it doesn't matter. You're working out. Here, what happens is I'm going to look at this here, and I'm going to plot this guy right here. This is a parabola with a vertex of -1, -1, -3. So just really sketching it quickly, -1, -3 is my vertex. Opens up because I'm positive. And now I want to talk about the inverse. Well, to get the inverse of this guy, the inverse will go like this because I have a reflection in the x equals y line right here. Okay, so there's a imaginary line here. I take this and I reflect it, it'll turn it like this. That does not pass the vertical line test. This fails the vertical line test. So how do we make this a function? We need to make this, we need to chop an arm off here. So we chop an arm off this. If you remember, we're left with that, and when we flip it, we're left with the root x shape, which passes the vertical line test. So we need to chop an arm off. How do we do that? We say we don't want this arm here. We only want x greater than or equal to -1. So I want all of this part of the equation. And then what happens here is that's the domain. The range of the inverse, then would look just like this. Y is a real number. Y is greater than or equal to -1. Okay, so when we plot this guy, we work our way down here. We swap this out here. X for y, and then we solve for y. So x goes where y is. So this is from up here. We swap x for y. Solve for y, bring the 3 over, take the root. We can take the plus minus equals this. And then what ends up happening is we put the plus minus there. But what ends up happening is when we restrict the domain here, it gets rid of the negative, the reflection, and we just have the positive part. And we have root x plus 3 minus 1. Root x plus 3, there's root x. Plus 3 means move left 1 and then down 1. and that's my vertex. And if you think of it this way, my new vertex is -3, -1, my vertex of my root x, that is, and that's if I swap the x for the y here, and that's what happens with inverses. Okay, so what happens? Again, chop the arm off, change the domain. Let's go to the next one. The next one became a big mess here. If you were in class, you noticed all this misery. First period was like the second period I gave up and started from scratch. These are your points. I've just made these points up here. It's actually not a function. I messed it up here. Fails the vertical line test right here. But anyway, it doesn't matter. Transformations are transformations. I have A, I have K, I have D, I have C, and they are -3, 1/2, 2, 1, and 4. Okay, so I look at the whole thing. So how do I get that? That's the transformation. -3, 2, 1, change the sign to +1 and +4. What happens? Symmetry here. Y, X, X, multiply, add, multiply by -3. It's a vertical stretch of 3, and it's also a flip in the x-axis. So all my y values are multiplied by -3. That's -3 times bigger. That's -3 times bigger. So this is how you get these numbers. Okay. These guys here are supposed to be -6. This is -6, -2, -2, +4, and +6. So these just stay as the same as this column here. Then the next step is to multiply everything here by 2. Horizontal compression of a half. Multiply everything by half. Okay. So all of these terms now, all of these guys here are half as big, and that's how you get this. Then add 1 to these because I'm going +1. And then after that, add 4 to these, and we're done. Sketch them if you can. They don't fit. My fault. Next. Woo! That's Unit 2 test done. Unit 3 test. -5 squared is 25. Negative exponent is flip. So 3 to the -2 goes up. 3, take the 2 with it. 5 comes down. 3 squared over 9. 3 squared over 5. 9 over 5. Here I have the power of a power law. Remember this? If I had this, like this, a squared cubed, it's a to the 6. Same if it's a number. 6 -2, 2. You multiply. Okay, multiply here. 2 times -2 is -4. 6 to the -4. A negative exponent means flip it. So it's 1 over 6 to the 4, which is 1 over 1296. Here I have 16 to the 3/4. That says I want the 4th root of 16 and then cube it. Okay, so this number is the top is a 3, just like here. If I had a 2, that's the same as 2 over 1 kind of, right? So the top number is the exponent, the normal exponent, but the 1 over 4 part of the 3/4 is the root. So I want the 4th root of 16 to 3. Now you can put this right in a calculator, 16xy to the power of 3/4 or 0.75, and you'll get the answer. But this is the 4th root of 16, which is 2, and then cube it, which is 8. All right, that's how you get that. Next up, you look at these guys here. They look a little better on your sheet. And exponent rules say when you multiply, you add. When you subtract, when you divide, you subtract. So I need to add. They're all to the same base. That's 2/5, 7/10, and 1/4. Add and subtract. 2/5 plus 7/10 minus 1/4. Lowest common denominator between 5, 10, and 4 is 20. Times 4 times 2 times 5, that's a negative. 8 plus 14 is 22. Subtract 5 is 17. X to the 17 over 20. Done. Here, I wanted to add an extra step here. That's 100. So here I have 100x to the 1/2. That's 100 to the half, x to the half. And the first thing we're going to do is dividing. We're going to write it like a fraction. Same thing. I'll just write it this way. This is 27 to the 2/3. X to the -2 to the 2/3. So let's deal with all this. 100 to the half is the root of 100, which is 10. So that's how I get this. X to the half is just x to the half. 27 to the 2/3 is the 3rd root of 27 squared. So what times itself gets you 27? That's 3. Squared, that's 9. So that's how I have 10 and 9. And now the only thing I'm missing here is this guy. Exponent rules, power of a power. -2 times 2/3, that's -4/3. So now 10 and 9, they don't reduce. If they did, like if this was 18, let's say, I could reduce this to 2 over 1, but I can't. So let me see if I can get rid of that. Okay, so 10 over 9 stays like this. I have x to the half over x to the -4/3. That's dividing. Dividing is subtract, but because it's negative, it's x to the half minus -4/3, which is 1/2 plus 4/3. Lowest common denominator between 2 and 3 is 6. I got 3 6 and 8 6. That's 11 6, and I'm done. If for any reason I had a negative answer here or here, let me just tell you. Let's say I worked the question out and I ended up with this. 6 over 5x to the negative 3. Okay, that's my final answer. That's that's what I figure out in my final answer. Well, I don't want negative exponents. I only want positive exponents. So I'd add one extra step, and I'd leave the 6 over 5, and I'd bring this x to the negative 3 down and make it x cubed. Okay, so be cognizant of that. Okay, so let's see. We have a base function of 2 to the x, and we are going to mess around with it, and we're going to see how we mess around with it. Well, this is a, there's k, there's d, and there's c, and I messed this up actually. Someone pointed out in class. Thank you very much. A is a quarter, so a is a vertical compression of a quarter. Next up is so here I had 4x minus 4 is my exponent. I need to common factor out here a 4, so I get x minus 1. So the 4 means I have a horizontal compression of 1/4, and the minus 1 means I'm moving right 1. So I messed this up here. Horizontal compression of a quarter, right 1, and then down 15. Again, vertical first, then these two are horizontal, and there's a trick to them. This guy 1 over, this guy negative is to the right, positive is to the left, and then finally I end up with D as 15, or down, sorry, no, C is 15, which is down, sorry, I never noticed that before. Anyway, down 15 with C. Okay, exponent rules, y equals ab to the x. We're coming up with a bunch of equations. I got 3 minutes to finish this video. A is my initial value, B is my rate of change, that's change. Also, A is also my y-intercept. So here I want to come up with an equation. What's my y-intercept? -2, so that goes here. And what is my B, or how am I changing this? This is times 5, times 5, times 5. There I go. There's my equation. Same sort of thing here. My intercept is 8. How do I go from 16 to 8? I multiply by a half. So I have half, or 0.5 here as my base. Okay, let's go to the next question here. Y equals AB to the x. My initial value is 2 million people. So I have the population at a certain time is equal to 2. And I'm growing at 0.85%. 8.5%, 8.5% as a decimal. Move that over twice to 0.085. I'm growing, so I add that to 1. If I was declining or losing value, it would be 1 subtract 0.085. So I'd end up with 0.915 as my B here. But because I'm growing, I have the 1.085, and that's the formula. That's it. And if I want to know what my population is in 2007, well, that's 2 years after the initial what the question says at 2 million, and I sub in 2 and I find it's that. The last question here is for C. I want to know when it doubles. So the double the population is 4 million. So I set it equal to 4 million. First step is divide by 2 here. So here I'm dividing by 2. I end up with 2, and that is gone. Is equal to 1.085 to the n. Now what I'm looking for is up here, and that's when we bring in our friend the log. Log 2 on this side, log is 1.85 on this side, that's garbage, and bring the n down. Now I have this on this side, I bring this over, and I divide, so log 2 divided by log 1.085 is 8.5 years. If this says when did it happen, you would say 2005 plus 8.5 years would be 2013, sometime in 2013 or before 2014, it could be your actual word answer. I'm down to less than 2 minutes. Second last question. Half-life question. 41 days, start with 7 grams. So 7's my A, great. My B, it's a half-life question, so my B is always a half. You can write that as 0.5 if you want. And now my exponent is T over my half-life time, which in this case is 41 days. Okay, so set that up like that. Then when you sub in, first of all, you got to figure out, make sure your time's right. This is in days, this is in years, so I change it. I multiply by 365 to figure out how many days there are. So the question is, what's the amount remaining with 547 days left? Sub that in here as an exponent. That's my exponent. You can put that into calculator as 7 times 0.5 to the exponent and put a bracket here. That divided by that, close bracket, and you end up with something like that. It might be a little bit different than that, but anything close to that is fine, okay? Depending on how you put it in your calculator. I'm down to 48 seconds. Last question. What's the initial value here? Is the A, which is here. What's my depreciation rate? I'm getting smaller. I had 1. I end up at 0.77. How did I get there? Well, if I subtract this, I end up with 0.23. That's what I took off. So I'm losing 0.23, which is that's nothing. 23%, 28 seconds remaining. 23% is my depreciation rate. And the last question, what's the value at the end of 2 years? It's V2. Throw in a 2 here, and I'm down to 18 seconds, and I end up with this, and fittingly, I end up with a 5 that nobody can read. Take care. 10 seconds left. I got nothing else to say. Let's just stare quietly for 7, 6, I'm still talking 5, 3, 2. See you tomorrow.